This is a very, very large topic area and something that would keep us all entertained for, at least a day. And so what I'm intending to do today is really just frame the presentation around a few reasonably high-level questions to do with modelling and its use in the limit setting context. And so I'm going to tackle these questions at a reasonably high level and with a fair degree of pragmatism. And so for both of those reasons, I'll probably end up creating a lot more questions than I answer, but we can deal with that at the end. So just to provide, I guess, some context for this modelling, these modelling questions, because we all know regional councils have to set limits. Limits have consequences across the four broad categories of values, as we saw in the questions that came out during John Quinn's presentation. Setting limits requires making judgments about the mix of outcomes that we would like to see in each of those value areas. To help with that judgment forming process, it's really good to have information about how particular attribute states change in response to changing levels of resource use. The problem is there are many, many relationships evident within a catchment. And this diagram, of course, you've seen from John and you know its origins. But you'll also appreciate that this isn't the complete picture. There are feedback loops and a larger catchment, because this is only a sub-catchment of the Ruamahanga. There are many, many more connections of significance. And so this really creates us with a bit of a challenge. How do we get good, usable information about how attribute states change in response to resource use across so many different interconnected parameters? And at present, really the only practical way of doing so is modelling. LAWF got to this point in its earlier meetings and reports when it concluded that, in essence, limit setting necessitates the use of models and modelling. So in that context then, what are the real top-level purposes of modelling and models? So I've listed the two here, which I think are, the core reasons for us being here, I guess. The first is to help decision makers make the judgment calls that are needed to set limits. And then later on, once the limits have been set, capacities identified and allocated, monitoring compliance with those allocations, either as at the individual enterprise level, whatever the enterprise happens to be, or as clusters of enterprises, just, I guess, depending on how the particular community of interest wants to approach things. So if we go back to the first purpose to do with limit setting, the first point, and perhaps one of the main points I want to make, is that the modelers aren't the decision makers. In my view, the modeler's role is to act as honest brokers of the information that gets fed into the decision-making process. And I'd like to illustrate that with reference to this diagram put together by one of our colleagues, Ton Snelder. So here we have how one indicator or one attribute changes in response to a resource use indicator. The role of the scientist and the modeler is to provide this relationship. It's not the role of the modeler to tell the community where on here we should be aiming to hit or to achieve. That's the job of the decision makers. While we're looking at this diagram, Here it's presented as a very clean, sharp line, and in many reports, that's the way you'll see it. I think when you see a diagram like this, it's really helpful to be thinking in terms of not a very sharp line, but one written by a very fat crayon, because of the uncertainties and errors of measurement and everything else that goes into developing this kind of relationship. So the first thing I think you should take out of a diagram like this is the direction of change. That if resource use increases, in which direction is the environmental indicator in this case going? The second thing you should look at is the rate of change. As resource use increases, does the attribute on the vertical axis change quickly, i.e. is the graph steep or is it flat? They're probably the two most important pieces of information in a diagram like this. The third thing, and only I think the third thing that you should be looking at, is the absolute value of this indicator for this particular resource use level. Okay? So I guess that's beginning to get into uncertainty and how to work with uncertain information. Okay, the second primary purpose of modelling and the use of models in our context, current context. The only point that I want to make in relation to this is that the integrity of our whole resource management or resource use management system depends on there being consistency between the models used in the limit setting process and the models used for compliance monitoring. Now, by resource use system, I'm referring to the process of setting limits, defining capacities, allocating those capacities, and monitoring for compliance with what's been allocated, either at the enterprise level or as clusters of enterprises. And I guess to really home in on something specific, if you use one version of Overseer to set limits, use the same version to monitor compliance. If the version changes and you want to use the latest version to monitor compliance, go back and revisit the limit. To my way of thinking, that's the only way we will get consistency. If we don't do that, we're kind of like using a ruler to measure, we're using one type of ruler to measure a particular distance or whatever, and coming along later and using a stretchy ruler to try and do the same thing, and we'll end up with problems. One thing that the modelling in this context is not about, primarily, is advancing the state of scientific knowledge and modelling accuracy. However, advances in knowledge, and in particular knowledge about the whole system and how it works, will be an outcome of going down this limit-setting journey. And in fact, in many respects, if we're not learning, if we're not gaining knowledge through this collaborative limit-setting process and the modelling and everything that's happening, the collaborative process probably won't be successful. So what am I really trying to say here? Well, I guess the best way I can sum it up is that the role of science and of modelling in this process is to serve the zone committees or the FITUA committees or the flag groups or whatever you happen to label your collaborative committee with. So science serving, not science leading. And from the work that we've done and others have done in testing or developing and testing collaborative processes, this is one of the fundamental things that has come out. It's really, really important that the committee owns not only the values and the attributes that are used, but owns the modelling, owns the system understanding. Okay. Moving on then to the next question. Do all of the values and attributes need to be modelled? Well, being realistic, it's not feasible to do so. It might be if your focus is purely on the biophysical, but then when you bring in the socioeconomics and cultural values, recreational values, even some of the fundamental water quality attributes, it's just not going to be feasible to model everything, given the time that's available to you to set limits, first time round anyway, and the cost. And it's probably not necessary to do so anyway. Very often it's possible to use surrogates, and if you're running out of time and budget and it becomes necessary to do that, then do it. You'll also find that there are a number of attributes that actually respond in pretty much the same way, and so why model them all? Use one as a surrogate for the others. You'll also find that there will be attribute values which won't change much, if at all, in relation to changing limits. The different limit levels that you'll look at in the scenario constructing and evaluating process. So be brave enough to drop them out. Alrighty, so how do we determine which models to use? And there are many, many reasons. I've put up there what I think are the four big ones. The magnitude of the issues to be addressed, I think, should be an important driver of the scope, the detail of the modelling that you commit yourselves to taking on. Time and spatial scales, as we've heard before, that are required to address the issues are also very significant determinants of the models one should use. Budget and time, we've kind of touched on that already. And finally, the availability of data and codified knowledge. Now, by codified knowledge, I'm not just meaning knowledge and information that's been able to be expressed in mathematical equations and perhaps put into computer code. I mean knowledge that has been organised sufficiently well for you to be able to draw relationships between resource use and outcome. Okay. That sort of information or priorities can be assembled into a diagram like this. So I think the key things that I want to touch on in this diagram are, firstly, if there's low pressure on the resource now and the rate of change is so low that you're not expecting pressure, significant pressure to build up over the next 10, 15, 20 years, start down here with models which are cheaper to build and quicker to run. Okay? Because as we move up here in terms of detail, the costs and the time involved in developing the model and applying them increases considerably. So in a sense, don't try cracking a nut with a sledgehammer. Of course, I'm not saying that if you start down here, you should stay there. Or it may be that you have a considerable or expect a considerable degree of resource use pressure to develop over the next 5 or 10 years. If that's expected, then for goodness sake, put in place the investigations and development programs that are needed to get the data required to run the more complex models to address the issues in a more satisfactory manner. So, think ahead, act strategically, basically. In terms of our current modelling capability, most of our water quantity modelling systems are up in this sort of area here, where we can deal with medium to high pressure type issues, because we have, if you like, a medium and high level of information on which to base our models. And really this is largely the result of time. We've had time to collect the flow data or the groundwater level data and so forth. We've had time over decades, basically, to develop the models and to learn how to use them constructively. We haven't had that amount of time in the water quality space. And so we don't have the data sets that would really, in some places, perhaps many places, Sandy and David can probably deal with this better later, but we probably don't have the water quality measurements in the detail and over the length of time that would justify more detailed models, both spatially and temporally. Given the issues that we face, though, one would hope that the investment and planning is happening to move our water quality modelling capability further in this direction than where we're currently at. This is just another way in which the models can be kind of summarised and located in terms of their ability to deal with different spatial and temporal domains, and it puts a few names on the models available. This is only a subset of them. I guess the thought often is expressed, well, why don't we just get a model from overseas and use that? The reality is we do. Many of the models that are used in New Zealand have been brought in from overseas, and where necessary have been modified to better suit our conditions. So probably the majority of the models on that diagram there have overseas origins, and in many cases continue to be developed and maintained internationally. This is an example of a modelling architecture that's under consideration for one particular limit setting process. It shows you how the various models would be connected together to translate resource use pressures into, by the time we get to the bottom down here, changes in flow, changes in nutrient concentration, changes in loads, and so forth. Of course, there's a need to translate or to transform that reasonably fundamental level of data into attributes of direct interest to us all. So, hidden behind each of these boxes is another suite of models to deal with socioeconomic attributes, cultural attributes, in-stream attributes, and lakes. As a general rule, this is my take on the current situation, most of the uncertainty on this page lies over here in the water quality space, and in the space of taking the final step, if you like, in the modelling chain to provide us with attribute values in the economics area and so forth. Okay, so just to show you, in the lakes area, we're well served with a couple of models here that David Hamilton and his colleagues have considerable experience in applying in the limit setting context. Okay, very, very quickly. Will the models that we start with see us right through the process? Probably not. Because the collaborative limit setting process is iterative. It unearths issues as it progresses. New models will more than likely need to be added to the suite to deal with those issues as and when they are revealed. No one model will meet all needs, and so it's important that the models work together effectively. That's what interoperability is. But equally important is the interoperability of the scientists and modelers using the software. That's probably the most important aspect of interoperability. Okay, so why model status quo? Well, I guess the obvious is all about building confidence in the model's ability to reproduce what we have observed and measured over the years. An important byproduct of this is helping people understand how we have got to where we are now. And that can be a pretty challenging hurdle to get over in the early stages of a collaborative exercise. And so this modelling is really, I suppose, becomes the bit of the lightning rod actually as people develop their understanding of how things work and how we've got to where we are now. Okay, finally, scenarios. I see two very different uses for scenarios. The first one is learning about how the system works, how it responds. And in this context, it's really, really helpful to push the system. But there's some dangers in doing that, and we saw this yesterday when Linda put up a map showing the consequences of putting half of the Motueka Plains in horticulture. And Chris's reaction was understandably, this ain't going to happen. And, well, actually, that's not the point. At least that's how I interpreted it. The point is, what would happen if we really pushed the system as a means of understanding how it functions? So when we did the Canterbury Strategic Water Study back in 2000, the fundamental question that we were asked to address is, does Canterbury have enough water to meet its foreseeable water demand from all sectors? So we assumed that all of the potentially irrigable area in Canterbury was irrigated. We assumed that a fairly large chunk of foothills went into forestry. We assumed some fairly impressive growth rates for Christchurch and the surrounding towns, which were probably greatly underestimated now. But the point is, we pushed, if you like, the Canterbury water supply system as hard as we thought, as hard as we reasonably could in the irrigation space to see what would happen. So it becomes really important when you're talking about the results of that to couch the results or to couch the information in the right language. And so in that context, it was always, if all of Canterbury's irrigable land was irrigated, would we have enough water? If we developed this amount of forestry on top of that, would we have enough water? So the second main area, I think, of using scenarios is exploring possible futures, both to unearth what it is that the community would prefer, I guess, as their 20 or 30 or 50 year target, but equally important, I think, to identify where the community definitely doesn't want to go. And then I guess the question as well, how do we manage resource use to avoid going where we don't want to go and to encourage people to take us to where we do want to go? And I think that's where we pick up on some earlier questions today. At the end of the day, we could end up with nirvana. But where we actually go depends on the individual decisions of many, many different people. And perhaps the resource management policy challenge is to figure out how you create the environment to encourage people collectively to move in a particular direction. And with that, we'll draw things to a close.